Okay, so this is video for 14 for rotation. Okay, we come back to this, the warm-up, the 90-degree counterclockwise about the origin rotation of this equation. Come back to that later, okay? All right, so the objective is locate image of figures by rotation, which is a turn. Okay, rotation is a transformation, so that means it's one-to-one, suggested by rotating the paddle wheel. When the wheel moves, each paddle rotates to a new position. When the wheel stops, the new position of the paddle, P dash, can be referred to mathematically as the image of the initial position of the paddle, P. So this would be a counterclockwise rotation, which is positive. In mathematics, the counterclock rotation is a positive direction, and the clockwise rotation is a negative direction. Okay, so this would be the positive 90 rotation, this is negative 90 rotation. Okay, notation for rotation. A fox in the box and a mouse in the house. For the counterclockwise rotation shown about the point O through 90 degree, we write R O 90. So this is rotation about center or point O by positive degree 90 degree. Now, you remember it says when we did the reflection, the textbook used this, and for rotation, they do like that. But since it's going to be confusing for us, we should do reflection and rotation. We should just write and ref. So you remember reflection, you write the axis of reflection, so like line, arrow or something, and then rotation, you should have center of rotation, or origin, or coordinate, or point, or whatever it is. Okay. Counterclockwise rotation is considered positive, and clockwise rotation considered negative. If the red paddle is rotated about 0 or about O clockwise until it moves into the new position, where the block, this is, I think this is red and this is black, or it could be the other way around. Then avoid confusion, R is used for reflection, we use this for rotation. See, so we just write, for us, we just write left and right. Okay, full revolution or 360-degree rotation about point O rotates any point P around itself so that P dash equal P. Okay, so if you rotate 360 degrees, you come back to where you were before. The diagram at the left below shows the rotation 390 degree about O. Since 390 is 30 degree more than the full revolution, the image of any point P under 390 rotation is the same as the image under 30 degree rotation. So that's this. Okay, so 30 degree rotation is the same as 390 degree rotation, and where the position end up being for the 90 degree rotation is the same as negative 270 degree rotation, because the 270 plus 90 is 360. You see that? Okay, so rotation about over 390 is the same as rotation about over 30 degree, and the rotation of 90 degrees is the same as rotation of O of negative 270. Okay, so that's what this is. Okay, and the theorem 14.4, the rotation is isometry. Okay, so we don't need to go through this. It's just remember the rotation is isometry. And following definition of rotation in angle measure x can be positive or negative, and can be more than 180 in absolute value. A rotation of a point O through x degree is a transformation such that if a point P is different from O, then OP dash is OP, and measure of angle POP is x. If the point P is the point O, then P dash equal P. So what this is saying is that, let's just call this P, okay, for this diagram, okay? If the point P is different, I'm sorry, this is O. Yeah, this is O. This is O. If the point P is different from O, right, then this distance from the OP, from the center to the original point and center to the new point, have to be the same. So the distance from the pre-image to the center and the image to the center have to be the same degree. That's what the rotation is. Have to have the same distance. And this move is the angle of rotation. Okay, so measure of angle P or P dash is X. Okay, so that's what how much you're moving. Okay, and if the P happen to be on O, okay, so if the point P is at the center of rotation, then P dash and P have to be the same because it can move. That's why it's moving. It's like a North Pole. You can move here. Okay, so that's what this is. All right, and half turn is 180-degree turn. Rotation of a point O through 180 is called half turn. About O, and usually denoted by H0. Okay, half turn about the origin. The diagram shows that PQR, where is P? PQR, and the image of that P dash QR R dash by half turn. Note that O is the midpoint of, so this and this is the same length, this and this is the same length, this and this is the same length. Okay, and using the coordinate half turn of HO about the origin can be written as X and Y become minus X and minus Y. If you go 180-degree turn, no matter what the coordinate is, the new coordinate is going to have, so this coordinate have X and Y, right? So this coordinate is minus X minus Y. It's not changing now. The order is the same, it's just the sign is changing. So if this coordinate is X and Y, this coordinate is minus X minus Y, and so forth. Okay? All right, so let's do some practice. State another name for each rotation. This one, there are a couple ways to go. So here's O and then P, right? And then let's say this is 50-degree and P dash. You can go this way. Then that would be rotation of O of negative 360 minus 50, so 310. That's one way to say it. Or you can go this way and go through 360 and then 50 more. So that would be rotation about O of, what is it, 360 plus 50, so that's 410. So that's another way to do it. You can do 2 revolutions as well if you wanted to. So this one, negative 40, would be this. This is 40-degree, right? So you can go this way, and then that would be rotation of O and 360 minus 40, so that's 320, and so forth, okay? So try these, okay, for homework. Okay, now this one. This is a rotation about the center of a triangle and where the P and S and T is going to go, and this is equilateral. Okay, so the P, okay, so from here to here, if you go from here to this point right here, this is 120, right? Because they're 360 degrees in one revolution. From here to here is 120, here to here is 120, here to here is 120. Okay, so if you rotate about the origin by 120 degree, P is going to T, and S is going to P, and T is going to S. Okay, and then if you go to negative 120, P goes to from here, you're going to go here, so S, and S is going to go this way, so T, and T is going to go P. Okay, and then the 360 degree would go back to where you were. So P is P, S is S, and T is T. Okay, now let's look at this one. Now instead of rotating through the original center, now we're going to rotate through T. Okay, so from here, S, then 60 degree, this would be 60 degree from here to here. So this is P. And about the t of p, negative 60 degrees is going to go to s. And rotation about the center of 240 degree of p, and that's positive direction, so you have to go counterclockwise. So this is 120, this is 240, so this is s. Okay. All right, and draw a coordinate grid on the chalkboard. When I gave you a grid, so in the grid below. Plot the origin and point 4, 1. Give a coordinate of half turn of A, the rotation about origin of 90 degree of A, and rotation about origin of negative 90 degree of A, and repeat the exercise. All right, so you do this for homework, and I'm going to do this right now. Okay. All right, so 4, 1. 1, 2, 3, 4, and 4, 1. This is A, original A. Okay. So half turn about origin of A. So this is what you do. Okay. So half turn means 180 degree. So you're looking at this, right? You turn this around 180 degrees. And look at this as if this is the regular grid. Where is this point? This would be negative 4 and negative 1, right? Negative 4 and negative 1. So that's where it's going to go. Negative 4 and negative 1. This is the A. Okay? And then rotation about 90 degree counterclockwise. So this one, you're going to move counterclockwise 90 degree. Where did it go? This, if you're looking at this is X and this is Y, this would be negative 1, 4, right? Negative 1, 4. That's where it's going to go. Negative 1 and 4. That's a B. Okay? So you can, I was trying to teach you different ways going against the clockwise, but I think this is actually more intuitive. So I'm just changing what I'm doing. Okay? So it's going to go there. Okay? And then the negative 90 means clockwise 90 degrees. So you're going to go clockwise, this point. Clockwise, where did it go? This is 1 and negative 4, right? 1 and negative 4. That's where it's going to go. 1 and negative 4. This is C. Okay? So it kind of makes sense. This goes here, and this goes here. Okay? So try that with negative 3, 5. Okay? And the rest of the program, I want you to do odd through page 10 tonight. Okay, that's a homework. Through page 10, so through 31. Okay, and then we go over this in the class, and then we do evens in the class tomorrow. Okay.